Hello friends, welcome to our website automationcommunity.com. This is the third part of the topic count and pack using PLC. So in the first video we have seen the ladder programming. In the second video we have seen the HMI designing. So today we are going to write macro code for this project and then we will do final simulation. So there are three kinds of macro codes. First is screen open macro code. So what that means, first of all, from screen, you can open this screen open macro. Here we will write macro code. So what it means, whenever I open my screen, the animated objects like this, I have to define its initial position when the screen is on. And I am clicking on this. Its address you can see over here, it is internal memory 10. So if I want to give its location like x coordinate and y coordinate, then I have to double click over it, and from the coordinates I will see its x and y coordinates. So let us make it round figure, like this is 280 and here also 280. You can round figure as per your data. For simplicity, I am round off this value to 280 and click OK. So here in the screen open macro, I have to give its x and y coordinate in initial position. So here I will write internal memory 11, yes friends, and internal memory 12. Here you can see its internal memory is 10. So 11 will be x coordinate and internal memory 12 will be the y coordinate for this object. So here I will write 280 and here also 280. Similarly, we will repeat these steps for this object and this object also. So let us click on this. Here right now just click cancel, and this is 450 and 280. So this is okay. So just close this, and here let us see its internal memory is 15. So its x coordinate and y coordinate will be 16 and 17 respectively. So 16 means x coordinate of this object, that is 450, and y coordinate is 280, same. Okay. Now same thing for this object. So double click on it. Right now click cancel over here and see the coordinates. Let us make it round figure like 365 and here 355. Okay, and click OK over here. So this is internal memory 20. So here internal memory 21. Here we have to write $sign, and internal memory 22 will be the x and y coordinates respectively for this object. So here it was 365 and it was 355. Let us verify it. Yes, see 365 and 355. So this is screen open macro. When the screen will open, these objects will be found at this position. Okay. So now close this and click yes to save this. So now we have to write screen cycle macro for animation of the objects. So again go to screen, select screen cycle macro. Now first of all you can see this is conveyor, and for its animation we have used this pipe and this pipe. Both has same internal address, internal memory 1. So I will write code for the animation of conveyors. So first of all we need to check whether the conveyor is on or off. So for that go to macro wizard. In the command line select the comparison instruction, and from if select the if on. So it will check if the variable 1 is on or not. So select our variable, that is our output y0. We want to check output y0. Click enter and update macros. close this. So you can see our code is written over here. Its syntax and everything is written. So this will check if y0 is on, then the code written within the if block will be executed. So here I will write internal memory 16, internal memory 1, that is you can see from here. This equals to 2. Now why 2? Say for example, if I write 0, then it will be off. If I write 1, then this animation will be in upward direction, and if I write 2, then you can see this animation will be in downward direction right now, which you can see over here like arrows. So now just close this loop by end if, select over here, press enter. Similarly, we will write code for this main conveyor. So just copy paste this. Now we need to change. This is our output y1. So here I have to select y1. Now click over here. So you can see its address is internal memory 2. So here we have to write internal memory 2. Again here also, if I will write 1, then these arrows will move in left direction, but we want to show in right direction. So I have written 2. So this is animation when the conveyor is on. Now we need to stop the animation when the conveyor is off. So again we have to write the code to stop this animation. So just copy paste this whole block, control paste over here. Now wherever there is on, we will replace it with off. So it will check if the y0 is off, then value of internal 1 should be 0. That 0 means this animation will stop. Same here, if the y1 is off, then this internal memory should be 0. 0 means it will be stopped. So this is all about the code for the conveyor animation, both conveyor animation. We have to write animation code to move this image. These are the pistons. Because we are not using the actual outputs, we are using the animations of HMI to visualize our project. So for animation, we need two positions, initial and final position. So first of all, this is the initial position. Okay. From here, let us select this is our final position. So you have to move your desired object to that final position. Now we will write code for this. So when this animation should start, when the output y2 is on. So again, copy paste this, copy paste this particular line. Here we want to check if the y2 is on, then what we have to do, observe that this movement is in horizontal direction. That means this is moving in x axis only. So we have to change its x value. So this is internal memory 10. So its x value is internal memory 11. So I will write internal memory 11. I will increase its value. So again I will write internal memory 11 plus 2. So what I am doing, you can see from here, initially internal memory 11 is 280. So what I am doing, I am adding this value to 280. So in steps of 2, this value will increase, and as this value will increase, this object will move in x direction. Okay. Again, we also want to move this when y2 is on. So let's drag it to its final position. Okay. Select over here. This object is internal memory 15. So its x coordinate will be internal memory 16. So this time what we want to do, this time we will reduce the x value. So this object will move in opposite direction. So here we have to minus value. 2. Now why I have written 2 over here? You can write any number over here. If you will write bigger number, then this movement will be fast, and if you will write smaller number, then this movement will be slow. Okay, so what we are doing, you can see from here, initially this object was at 450. We want to move it backwards, that means left side, so we have to reduce its value from 400. So here I have written minus sign over here. Now we will close this loop. I end if. But friends, what this code will do, it will keep moving in particular direction. That means if this block is moving to right, it will keep moving. We have to define when this animation should stop. So again press enter. We will write one condition. If internal memory 11, that means the x coordinate of this selected object becomes equals to, now here comes the final position. You can see this is the final position of the object. So double click it to know its coordinates. Right now cancel over it, get the coordinates. You can see this is 341. Let us make it round figure like 340. Now you can see initially internal memory 11 was 280. Then what we did, we kept adding 2 and we get a final value of 340. So when this value internal memory 11 becomes equals to 340, this code should stop operating. Okay, that means animation should stop. So what we will do, first of all, we have to stop our y2. So here go to macro wizard and from here select bit off, and here in the variable we have to select y2 because we want to off the y2. Click on update macros and close this. See friends, in real life application, what we use to detect the final position of pneumatic cylinder, we use limit switch. Okay, but here we use the HMI code that if this position reaches to the final position, our pneumatic cylinder should be off. Okay, now what we want to do, we want to get this object back to initial position. So here I will write internal memory 11 equals to 280. So it will, how you can know this 280? You can see from screen open. Initially it was 280. Similarly, internal memory 16. That means this object also should go back to original position. Now how can you know the initial position of this? So go to open and here you can see initially it was at 450. So again here I will write 450. So these objects will go back to its initial position. Now we want to close this if loop. Okay, so here we will write and select this end if, enter. So this loop will be closed and this is the code. Okay, from here to here, this is the code for animation of these two objects. Now finally we will write code for animation of this object. So again come over here, press enter. When this animation should start, if the y3 is on, then this animation should start. So I will use this code to check whether the y3 is on or not. So here I will just write y3 and it will check. If this condition is true, then what should happen? We want to move this. Let us say this is the final position of this object. So first of all, right over here, you can see from here it's internal memory 20. So it's Now this movement is in y direction. So what is the y coordinate for this object? Internal memory 22. You can see from here. 21 is x coordinate and 22 is the y coordinate of this object. So here I will write internal memory 22 equals to internal memory 22 plus 2. What it will do? It will increase, sorry, now if we will increase the value of y coordinate, it will move in downward direction. If you want to move this in upward direction, we have to reduce its value. So here I will write minus. Now you will be asking, how can I come to know whether here should be plus or minus? So the answer is very simple. You write anything over here, plus or minus, then run your simulation, and you will come to know that if you will write minus, this object will go in upward direction, and if you will write plus over here, this object will go in downward direction. You can examine it by yourself only. So it will start moving this block upward, and here we want to close this loop. Now we will write when this animation should be stopped. So when this reaches to its final value, that is, if internal memory 22 becomes, so now double click over it to see what is initially it was here. Then I dragged it to the final position, and now I will check its coordinates. So its final value is 370. So let us round figure it to 315 and click OK. So here I will write 315. First of all, here I have to write equals to, then now what we want to do, first of all, we have to off this Y3. So again select this code bit off, that means particular output will be off, and change it to Y3. So first of all Y3 should be off, then what should happen? This should come back to original position. Here I will write initial position, you can check it from here. Initially it was 355. So here I will write 355, and then I will close this loop. Select this and press enter. So friends, here we have completed our macro programming. Now close this and save it by clicking yes over here. So friends, here we have completed our HMI designing. Now it's time to do simulation. First of all, open your ladder programming in ISPsoft software. Then from here you can open ComGR and select your simulator and click on start button, then close this. So first of all we will compile this project. Now click on compilation is successful, so now click on download button and click on transfer. Just click on close button and go on online mode from here, and don't forget to on this bit and press enter. Now click on run button, confirm yes. So here you can see the status, it is in run condition. Now open your DOPSoft HMI again and click on offline simulation. Observe right now this is in this position, and what happens when I click on this. So you can see in my HMI screen, these are here, okay, but when I am doing simulation, it has came to the position which I have specified in screen open macro. So this is the use of screen open macro. Now first of all, here in the set count you can see 0, and in the D0 also you can see 0. So whenever user will click on this, you can enter any value from here. Let us say I am entering 5 and click enter. So you can see the value given by user has moved to D0 register. Now when I will press the start button, this will on for one instant and then this bit will be latched and remain on even if I unpress this button. So I am clicking this. You can see this bit is latched. Okay. Now this code is run because you can see counting is not completed. Process is on and counting is not completed. So our sub conveyor is on. So you can see its animation from here also. These are the animation for conveyor. It's working. Okay. Now when product will pass through this sensor will get activated. So right now I have to click it by ourselves only. So you can see I have pressed this. It has given pulse to this counter and counter value is increased. Here in the HMI display we can see right now there is one product in the box. Similarly, when another product will pass, counter will increase. Observe this. Now when the present value will be equal to set value, this will open and it will stop the sub conveyor and it will give pulse to this packing machine Y2. So observe carefully, and here also the animation will start. So as soon as I am pressing this button, Y0 is off, this conveyor is off, its animation is off, and Y2 animation, that is pneumatic cylinders are working. When it will reach to final position, you can see Y2 is off, Y3 is on. You can see Y3 is on, its animation is working. Now it has reached to final position, so it came back to the original position, and now the packed box is moving in forward direction by main conveyor. Main conveyor, you can see main conveyor is on over here. So let me explain this codes also. When this counting was completed, it simply latched our output Y2. From the HMI code, if you remember, I have written bit of instruction. When this animation reached to its final position, it executed bit of instruction to off this Y2. So when this Y2 became off, that means the falling edge. Y3 started. This is just a latching circuit, okay? So as the Y3 started, this animation executed. And again, when it reached to its final position, I have written bit of Y3. So Y3 become off. So when Y3 become off, this is again the latching circuit. This is the start, this is the stop button. So this Y3 falling edge is detected. So our main conveyor Y1 become latched, and you can see main conveyor is on. So what will happen? The packed box will move in forward direction and empty box will come over here. So when empty box is reached, it will be sensed by our X3 sensor. So observe this. When X3 sensor will sense the empty box arrived, this bit will turn off our main conveyor. So I am clicking over here. So you can see main conveyor is stopped, and when the main conveyor is stopped, that means falling edge detected, counter is resetted. So you can see from here the present value of counter becomes 0. That means our process started from the beginning. Now again, here is the new box, the new products are coming, it is sensing. You can see 3 products, right now 4 products, and this is the 5 products. So again packing started. You can see this is the packing process. 2 cylinders are pressing the side of the box. Now Y2 became off. This is packing machine, another output Y3. Now box is packed, it is moving in forward direction. New box is arrived and process is repeating. So friends, I hope you like this project. I know this project has become very long, so I have to make it in 3 parts. So friends, if you want to learn more examples like this, show your support by liking our YouTube channel instrumenttools.com and automationcommunity.com. Meet you in the another video with new topic.